Good afternoon, everyone. My name is Amit, and I am Solutions Lead for Content and Data Intelligence Portfolio for Hitachi Vantara in APAC. Today, we're going to talk about the role of object store and how it is changing in high-performance Tier-1 workloads. So with that, let's get started. This is a quick agenda of what we're going to cover. We're going to talk about how role of unstructured data is changing in today's enterprise scenario, and how a data platform should behave. What are the characteristics of this modern data platform? And how object storage has evolved throughout these years. And then we'll look at how object storage and performance can be fine-tuned to meet our requirements. And then we'll look at some real-life examples of how object storage are being used in high-performance Tier-1 workloads in some of our clients. I'm sure all of you would agree to this slide that almost all of the data that we have in our enterprise is largely unstructured. And as per Gartner, by 2024, the data that is being stored as file or object would be 3 times more than today. And when I say unstructured, what I mean by that is the data that is in the form of files, documents, images, audio, video files, and also the semi-structured data like machine data, sensor data, or email, social media communications, etc. This data has been classically considered as a cost burden. It was stored more for regulatory compliance. It was stored more for archival. It was stored on a secondary or tertiary tier. And it was just used for search where it was required to respond back to the auditing kind of queries. But today, it's being looked at a source of data for analysis, source of data for generating more meaningful insights, source of data for generating new revenue streams, creating right data governance policies by looking at this data. And again, this data can again further be categorized into data that doesn't need to be read and data that needs to be read, searched, analyzed. And then you create a hybrid cloud or a multi-cloud strategy wherein some data can reside on a high-performance object storage, whereas other set of data can reside on a low-cost, deep archival tier, maybe in the cloud. Now, with that, let's look at what are the modern use cases and how the object store is being used or is being seen by some of our customers. So in the past, object storage systems were majorly being used to archive the data for replacing tapes, and it was majorly write once and never read again kind of workload. But today it's being used more and more along with data analytics and data lakes to analyze this data. In the past, the applications that were used with object store were more like mode 1 applications. They would just dump the data and will never read it back or read it just once in a while. But today, object storage systems are being accessed by the mode 2 applications that need high performance, that dictate the speeds in gigabytes per second, and even larger than that. In the past, the object storage systems were like monolithic appliances. They were more rigid. They could provide the scale, but they were not software defined. Today, the object-based storage systems have gone software defined. You can choose the hardware of your choice. It could be the commodity servers, or it could be even the purpose-built appliances from the various leading vendors. And the entire solution sits on that is a software-defined solution. It's a native hybrid cloud solution. In the past, the scale was monolithic, like you add an application and you add more storage required for that application. But today, we know that more and more development is happening in a containerized fashion, in which containers can be scaled up or added and destroyed on demand. With that kind of development, you also need more granular scaling. And today, object storage systems have been designed to meet these kind of requirements. And finally, the metadata. In the current environment, uh, the metadata that is used is not only used to lifecycle the data, which means to move data from a tier 1 to tier 2 to tier 3 and then finally destroy the data, but it is used for governance, it is used for creating more meaningful searches, providing more insights to the data that is getting ingested at source itself. With that, your data becomes more active, more live, and more searchable. Now, if that's what is happening with object store today, what are the pillars or characteristics of this modern data platform or modern object-based storage data platform? I believe these are the 6 pillars that uh, define or characterize a modern data platform or a modern object store. It must be simple, secure, and smart. It, it has to be API driven because it should let me consume the object store through the RESTful APIs, S3 APIs, or open APIs within my applications. It should let me customize my applications to consume the object store and not dictate how it should be consumed, right? It should support multi-cloud, multi-protocol use cases. It should limit me to a particular type of protocol or interface. It should be true limitless and global in nature. It should expose a global namespace view of my data, irrespective of where it resides and how it is being stored. I should have a single pane of glass to store, protect, and manage this data. It should be metadata based. I have taken this example earlier. Metadata makes your data more active, more agile, more living. So by attaching specific custom metadata that you need for your specific use case, object storage system should be in position to blend the data with the custom metadata. And finally, I believe it has to be software defined because being software defined means that agility, means the flexibility, and you can deploy it anywhere and you don't have to be bound to hardware. With that, let's look at how object storage has evolved throughout these years. Object storage is not new. It's I think more than 25 years right now. It was introduced sometime in 1995. But since then, it has been evolving. Early days of object storage was more like a worm storage, write once and read many times storage. It was used for archival, it was used for tape replacements, it was used for compliance, and mostly for storing the data, which is static data. With the public cloud becoming more and more prevalent, all object storages in the industry started evolving and started providing native cloud support, native S3 REST API support, and they have started becoming more metadata aware, metadata enriched kind of platforms. With the open APIs, you could just have your own application, custom APIs developed to use within your environment. It's native multi-cloud because of the need to talk to public cloud vendors like Amazon, Google, Microsoft, etc. But with more focus on analytics, with more focus on how can I drive intelligence out of my data, came the clustered analytical solutions like Hadoop, Splunk, Spark, etc. Now, today, object storage systems have become integrated part of these scale out data analytics solutions. Data lakes built on Hadoop ecosystem or Spark ecosystem can ingest huge amount of data, analyze that data, churn out the outcomes. But you know that these solutions uh, work on a principle of creating multiple copies of that data, hold that data because it should be easily available when it is required, and they use commodity hardware to create this cluster. It's good to start with, but when you start growing, your data increases in tens of petabytes. You would start these solutions start becoming more complex and difficult to manage, and the overall total cost of ownership starts increasing. And that's where comes a sophisticated search and offload capabilities that object-based storage systems can provide. So today, object-based storage systems can integrate with Hadoop and can replace the multi-copy storage that Hadoop ecosystem or these clustered systems use to store the data. You still need these solutions to churn out, analyze this data, but it can be only used to hold hot data, and all the warm data, all the cold data can be offloaded to object-based storage. With that, you can have a very intelligent data management layer inbuilt into your next generation applications, and that's what we are seeing more and more customers adopting today. This is an example how object storage systems are evolving and extending beyond data center, going much beyond data lakes to data ocean, I would call. With open API support, REST API support, you can use applications such as Hadoop or Splunk to offload the data natively within their ecosystem onto an object-based store. And beauty is that if you fine-tune object-based storage systems to meet that retrieval performance, the object-based storage can become the inline tier for your warm data, and you don't need to store multiple copies of your warm data or cold data within your analytical clusters. With the next generation databases like Greenplum, and with the solutions that supports S3 natively and S3 Select natively, the object-based storage system can replace the entire HDFS for such workloads. And we are seeing the applications today like Greenplum work very well with object-based storage. Applications like Spark, Hive work natively with our object-based storage systems that supports S3 ground up. And again, there are a lot of new next generation applications that further expand this use case into and outside your data center, such as S3 applications, high performance file systems, Splunk kind of workloads, and etc. So with that, you easily can extend the reach beyond your data center and have more and more data sources participating in your truly global data lake architecture built with object-based storage systems. Now, a quick glance on how object storage and performance go hand in hand together. We all know object storage systems means system that is built for archival, not for performance. But what we have seen is if the object-based storage systems have been deployed with right infrastructure and right tiers, it can provide you right performance that can actually serve almost all your high performance workloads. And this is a simple test bed that we have tested the performance on, and these are some of the results that we have achieved. Let me take you through that. We have seen the performance scales linearly with the scale. So you see on the first graph, the performance of 8 node versus 16 node versus 24 nodes, and it's scaling linearly, and that's the beauty. A simple 8-node system can deliver close to 19 gigabytes per second read throughput, and that's a throughput that you can easily go with if for most of your applications. On the left hand side, you see that graph that talks about time to the first byte. We have seen the response times are as small as 15 to 20 milliseconds. And with that kind of time to the first byte, your analytical workloads, your file workloads can natively reside on object storages today, and you need not have to have another layer to store and analyze this data. And that's the reason I'm saying today, most of the high performance workloads can work with object-based storage systems if you design the systems to meet the required performance in terms of throughput, in terms of operations per second, or in terms of latency. And again, today, with the prevalence of NVMe, prevalence of flash, we have the high performance storage layer also at our disposal. So if you leverage these resources well, you can very well meet the performance from your object store. This is an example of how it is being deployed in some of the real world examples. So in a big data analytics use case, one of our customer has deployed object-based storage from Hitachi to get about a terabyte per minute throughput, a TB per minute ingest rate, and retrieval rates achieved with an object-based storage. With that, Hadoop ecosystem now can work with object-based storage to push the data for that doesn't need to be analyzed, but still need to be searched, still needs to be stored for reference. And Hadoop can only focus on the churning that data, analyzing that data. In another example, we were able to achieve what 12 gigabytes per second throughput with a trillion plus objects coming from 56 different applications in a global data repository use case. In a content distribution use case, this was done for a media distribution customer, and it was a geo-distributed cluster with 9 petabyte plus scale, with 4.6 million plus videos and 1,200 live streams, streaming data from the object-based storage out of the box. Now, how does this 1 terabyte per minute look like? You may have that question in mind. So here is an example of the Hadoop and Hitachi content platform, which is an object-based storage from Hitachi, are working together to provide a terabyte per minute kind of throughput to store the warm data that needs to be searched in real time by the applications. If at all you're wondering how this is possible, we were able to work closely with our partners here to figure out the kind of ingest rates and the throughputs required, and we could size that object-based storage to meet that performance. So idea behind showing this slide to you is it's no more just dumb archival platform today, but more than that, it's a high performance object-based storage that can work with you and provide you right performance, right throughput, right scale to meet your newer workloads. And to instantiate, I'm sharing with you some of the research white papers that we have published, and the performance testing benchmarks that we have that kind of proves that today object storage has become the foundational technology for tier-1 workloads, going beyond just pure dumb archival storage. And with object store, you can uncover the treasure in your unstructured data. With that, I would like to thank you all for giving this opportunity, and you have a good day. Thank you.